Hello, a good day to you all. So let's discuss about LED circuits and how one would go about designing one of these circuits for a given voltage or a current source. So if you examine any LED circuit, you can see that it is composed of a source, a current limiting resistor, and the LED itself. The source may be AC or DC, and the current limiting resistor is there to limit the current flowing through the LED in order to protect it. So before delving into the details of designing these circuits, let's go and take a look at an example LED datasheet in order to determine the parameters we need to use when designing these circuits. So let's look at some LED specs on the internet. So this page is from Sparkfun, where they have advertised about their basic 5mm red LED, and I'll provide a link to this in the description. And they have provided a small description about the LEDs, and it basically says that about what an LED is, and they say that the typical forward voltage is 2 volts and the rated forward current is 20 milliamperes. So features, of course, the drop can be 1.8 to 2.2 volts DC forward drop, max current 20 milliamperes, and the suggestion they have provided 16 to 18 milliamperes. This is the luminous intensity, the luminous intensity is the measure of how much bright the LED is. So we'll proceed to documents and the datasheet. I'll also provide a link to the datasheet in the description. So looking at the datasheet, you can see that it is provided by China Yangsan LED Technology Corporation Limited. So they have given a model number. And what we are interested in is the absolute maximum ratings and the operational characteristics of the LED. So one should make sure that whenever they are operating, whenever they are designing the LED circuit, the LED should not exceed absolute maximum ratings. It will definitely cause the LED to fail, or the operation would not be reliable afterwards. So they have first provided the forward current. As you know, the LED is basically a diode. LED stands for light emitting diode. So it can only flow current in one direction, which is so the direction will be forward current. Forward current means the direction it can flow. So the absolute maximum rating is 20 milliamperes. So you should not exceed this value. And the peak forward current, of course, you may provide slightly above than the forward allowable maximum forward current, which is 30 milliamps, 20 milliamps. You can let 30 milliamps flow for a very small period of time, and that is the peak forward current. The suggestion on using the current is 16 to 18 milliamperes, as it was said in the description as well. So actually this is a good datasheet. It also provides you what you should use. I mean, you may choose to drive it using 20 milliamperes, but of course it's better to use it this range. The reverse voltage, of course, as you know that the LED will not turn on if the voltage is in the reverse polarity, and at 5 volts you can only allow 10 microamps to be flown through the LED. So this is a critical. This is they haven't allowed us much tolerance here. So basically if you allow more current than this, the operation would be unreliable or it would fail altogether. The power dissipation, this is also a very important parameter when it comes to LEDs, because one should make sure that the power dissipation does not exceed the maximum value, which is 105 milliwatts. So as you know, the power is calculated by voltage into current, and we'll also include this parameter in our design as well. So the operation temperature, we do not really care about this in typical applications, of course. But if you take it to the extreme, you may only use it on above negative 40 Celsius and positive 80 below positive 85 Celsius. The storage temperature is right above that, negative 40 to 100. The lead soldering temperature is given to us as 260 Celsius for 3 seconds only. So as a rule of thumb, you should only put the bow tip on the whatever the lead you are soldering for maximum of 3 seconds. And Also, more absolute maximum ratings for a room temp at the room temperature 25 Celsius. The forward voltage and a forward current of 20 milliamperes should be 1.8 minimum, and maximum should be 2.2. So the typical value, you may use anything within this range. The wavelength is given to us for a forward current of 20 milliamperes is between 620 to 625. So as you may know that this LED is a red one. So if you look up on some electromagnetic wave length electrospectrum, you may see that red belongs in this region. That is why the wavelength is 620 to 625. The luminous intensity is given in MCDs. It's between 150 to 200. The viewing angle I will explain later. Again, under 20 milliamperes is 40 to 60 degrees. So this is important. So although this is a red LED, they have provided some information about other colors as well, as yellow, blue, green, cool white, pure white, warm white, and so on. So this is the light degradation in MCDs. So as you may see that after 216 hours it drops in 1.52 of the maximum light intensity. So they have provided mechanical dimensions, and as you know, this is a 5mm LCD which is the diameter is 5 of the lens, and as I mentioned earlier, this is a lens which disperses the light coming from the small chip inside it. This is the viewing angle. If we enlarge on it, so that's it. So let's get back to designing the circuit. Okay, so now that we have looked at the datasheet, we know exactly what values we should use, like the forward current, the forward voltage, and the maximum power distribution that is allowable for the operation of the LED. So let's note them down and start designing the circuit. So the forward current is provided to us as should be between, they said 16 to 18 would be a good value. So let's choose 80 milliamps. Afterwards, the forward voltage was allowable between 1.8 volts to 2.2 volts. So we'll choose 2 volts. And the maximum power dissipation was given to us as PD, power dissipation, 105 millivolts. So let's take these, let's keep these values in mind and design the circuit. So as I mentioned earlier, the most trivial circuit consists of power source. In this case, we'll choose a DC power source, and the LED itself, and the current limiting resistor. Now, when it comes to the circuit, the orientation, the placement of the resistor does not really matter, since it's the polarity for a resistor, there is no polarity, so you can just put it either above the LED or the below, so in the ground side or in the positive side. So the most trivial circuit consists this way: a power source, the LED, and the current limiting resistor. So our challenge here is determine R for a given voltage source. Now, for the sake of argument, let's assume that this is a red LED and these are the values that we should adhere to. Alright, so now when designing the LED, let's assume that we need the circuit to be run using two 1.5 AA cells. Okay, so let's design a LED circuit to be powered by two of these AA cells. Now each of these cells is rated for 1.5 volts. So we need at least two of these cells in series in order to obtain a sufficient amount of voltage to power the LED circuit. So if we hook up two of these guys together, we get 3 volts. So we have a LED. Now always make sure the LED, the positive side is hooked up to the positive side of the batteries, and the negative side is the ground of the circuit, which is the negative side of the LED. So we have a current limiting resistor here, R. So we have to determine the value of the R. So now our forward voltage drop is 2 volts. So we need to make sure the LED, the VL voltage of the LED is 3 volts, is 2 volts, and in order to make up the entire amount, the resistor should keep 1 volt. So using and we also know that the forward current, or as IF, is 18 milliamps. So what we need here is now the Ohm's law, V equals IR. Now we know V and we also know I, and this is for the resistor. So what we need to determine is R. So in order to isolate R, I'm gonna divide voltage by current. So voltage is 1 volts, I is 18 milliamps, and that turns out to be 1 over 18 10 to the minus 3 amps volts, 1000 over 18. So the value turns out to be 55.55 ohms. So the nearest value resistor we can get is 56 ohms, the practical value available in the market. So now we know the resistor value we should use. So in order so let's redraw the circuit. We have two AA cells, each measuring up to 1.5 volts, and the entire voltage source is 3 volts. We have the LED, the red LED, and we have a resistor 56 ohms. So there you go, this is the circuit.